Have you ever wondered how all that food at the grocery store stays fresh? It all comes down to water. We're here today with recent graduate Alex Weaver at UF's Food Science and Human Nutrition Department to learn more. Alex, thanks so much for joining us today. Could you tell us more about what happens in this department?
The UF Food Science and Human Nutrition Department is within the College of Agriculture and Life Science. So as is in its name, it focuses on two things, food science and human nutrition. So this is the FSHN pilot plant. So around you, you'll see, other than our desiccator, some fermenters, carbonators, blanchers, other food processing equipment that aims to teach undergraduates and graduates about the value of food processing and the ways in which food can be made shelf-stable and more nutritious.
How does the desiccator remove water without removing the quality of the food?
Sure. So there are two different kinds of water in food. There is bound water and then there is free water. So when you heat food up or pass air over it that is less humid than the food is, you can say the food is humid or the water activity of the food, you remove that water from the food. Typically, foods that you will see on the shelf in a grocery store have a moisture content of less than 30%, which means that they inhibit mold growth, bacterial growth. Anything that needs moisture and nutrients to thrive will thrive in a humid environment. So if you remove that moisture from the food, you have a shelf-stable product.
How does this desiccator differ from previous models or from what they had to start with in this department?
Also a really good question. So Dr. McIntosh, when he came to us, had a pie-sized dehydrator that was maybe about 1.5 feet tall that could only contain maybe 200 to 1 kilogram of food, 200 grams to 1 kilogram of food. And so when he came to us, he asked if we could quadruple the capacity of that desiccator and also implement additional features like air heating, air pressure regulation, air flow regulation, and then allow him to conduct 4 separate experiments at once so that, again, he would have that additional capacity for his students and for his researchers.
And your involvement with a project here recently actually comes from an engineering background. Could you talk a little bit more about how you got involved?
Yeah, absolutely. So like you said, I personally come from the chemical engineering department. My colleagues Stanley and Corinne, they came from the mechanical engineering department, and then Virginia came from the biological engineering department. And so we really had a rounded set of skills that covered everything from psychrometrics on the chemical and biological side to the actual structural manufacturing and static analysis of the load cell structures in this machine under the integrated process and product design course to formulate and design and end up validating a desiccator that would provide value to the Food Science and Human Nutrition Department.
And you guys have some really exciting news coming up, right? Tell us about what you guys are going to be doing next.
We do. So we were invited to the Capstone Conference in Knoxville, Tennessee. This is a capstone design conference for senior design students around the country, not limited to integrated projects. So anything mechanical, biological, chemical, civil, electrical. So we were invited to this conference to present our design work on the desiccator primarily, and our design thought, focus, validation focus, and kind of go over some of the troubles that we encountered in this process and how we overcame them as a team.
Thanks for joining us. We hope you learned about the intersection of engineering and food processing. And we'll see you next week on another Tech Tuesday.